All right, let's dive right into this. Welcome to today's explainer. Today, we're pulling back the curtain on one of the absolutely most critical, yet honestly least understood frameworks in all of global aviation. We're looking directly at the official Icao Annex 13 document, and we're specifically zeroing in on chapters 3 and 4. This right here is the International Rulebook. It dictates exactly what happens the very second an aircraft experiences an accident or incident. If you've ever wondered how the global aviation community manages to coordinate a massive response across borders, languages, and jurisdictions in a matter of literally minutes, well, this is the foundational text that makes the whole shebang possible. So here's our quick roadmap for this explainer. 1. Safety, not blame. 2. Securing the scene. 3. The global alert system. 4. Anatomy of a notification. And 5. The international response.
Okay, Section 1, Safety, not blame. The philosophy of investigation.
Now, before we get into the physical protocols and that ticking clock of global notifications, we really have to establish a fundamental and frankly kind of surprising truth. When a major aviation incident makes the news, you know how it is. The public and the media immediately start asking, whose fault is this and who's going to get sued? But Annex 13 explicitly dictates that crash investigations are absolutely not about finding out who is liable in a court of law. The focus is purely 100% on future safety and the prevention of accidents and incidents. Listen to this direct quote from Chapter 3.1. The sole objective of the investigation of an accident or incident shall be the prevention of accidents and incidents. This isn't just some nice theory or a gentle suggestion. This is international law. And this paradigm shift, it's the secret to why aviation is incredibly safe. By completely removing the threat of legal liability from the immediate investigation, you encourage total transparency. I mean, people and organizations are far more likely to share critical data if they know it's being used to fix a broken system rather than to throw them in jail, right? And to guarantee this pure focus on safety, Chapter 3.2 demands a completely independent investigation authority. This means the investigators literally cannot be the same people who regulate the airlines, and they absolutely cannot be subject to political pressure. The whole process has to remain entirely objective and totally free from regulatory interference. The investigators answer to one thing and one thing only: the facts. Moving on to Section 2, Securing the Scene, Ground Zero Protocol. So we understand the philosophy, but what actually happens on the ground in those chaotic minutes and hours right after an event? Well, Chapter 3.3 outlines the primary responsibilities of what Icao calls the state of occurrence, meaning the country where the incident actually happened. That nation is immediately responsible for the physical protection of the evidence. They have to establish safe custody, and this isn't just about throwing up some police tape. It's a strict mandate to protect the wreckage against further damage, totally prevent access by unauthorized persons, actively stop any pilfering or looting, and prevent the deterioration of critical evidence, like those crucial flight recorders, long before the international experts even touch down. Now, there is a reality check built into Chapter 3.4. While the golden rule is do not touch the wreckage, there are strict life-or-death criteria that dictate the only acceptable reasons you can disturb the scene before international representatives arrive. First and foremost, obviously, to extricate trapped persons, animals, mail, or valuables. Second, to prevent destruction by fire. And third, to eliminate an immediate danger to air navigation or the general public, like, for instance, if debris is blocking an active runway. Otherwise, everything stays exactly where it is. Section 3, the Global Alert System, triggering the notification. Once that physical scene is secured to the absolute best of the local authorities' abilities, we shift focus from the ground straight to the sky. A massive, urgent communications web has to be activated next. Chapter 4.1 injects this incredible procedural momentum and a real ticking clock urgency into the process. The state of occurrence has to send out a notification with a minimum of delay and by the most suitable and quickest means available. There's no waiting for the morning briefing. There's no waiting for the dust to settle. This is a global emergency, and that alert has to go out instantly. But who exactly is getting this urgent notification? The state of occurrence must immediately alert a very specific list of players. The state of registry, where the plane is registered. The state of the operator, where the airline is based. The state of design, where the plane was engineered. The state of manufacture, where it was physically built. And finally, the International Civil Aviation Organization itself, provided the aircraft is over 2,250 kilograms or is turbojet powered. This just goes to show the truly massive global scale of the immediate response. An incident in one country instantly triggers specialized teams in 4 or 5 other nations. It spreads like wildfire. And because this notification goes out globally, spanning different languages and time zones, standardization is absolutely everything. And you know, aviation loves its acronyms. Chapter 4.2 decodes the exact terms investigators use on the wire. You got ACCID for a full-blown accident, SINCID for a serious incident, and INCID for a standard incident. When these specific codes flash across the aeronautical fixed telecommunication network, the receiving nations know exactly what level of crisis they're dealing with the second they see it.
Okay, Section 4, Anatomy of a Notification, breaking down the data.
So the alert goes out. But what exactly is packed inside this urgent message? It's definitely not just a quick, hey, we have a problem. There is a massive amount of required information, and Chapter 4.2 details this with incredibly dense legal text, demanding everything from the pilot's qualifications to the physical characteristics of the terrain. It looks completely overwhelming, right? Well, actually, scratch that. Let's break it down simply.
In practice, it's like a giant puzzle, and we can logically group all that dense required data into 3 easily understandable categories. First, flight details: when it happened, where it took off from, and its exact latitude and longitude. Second, aircraft and environment: what kind of plane it is, how badly it's damaged, and what the terrain looks like. And third, people and cargo: the pilot's qualifications, the exact number of souls on board, and crucially, any dangerous goods down in the cargo hold. Now, here's a massive, critical caveat from the text. Dispatch of this notification shall not be delayed due to the lack of complete information, and it must be prepared in plain language. Speed completely trumps perfection in this early phase. If the state of occurrence doesn't know the exact number of passengers yet, they do not wait to find out. They send what they have in plain language so there are 0 translation errors, and they follow up with the missing pieces later as mandated by Chapter 4.4. Which brings us to our final section, Section 5, the international response, the chain reaction. We've seen how the scene is secured and how the notification is perfectly structured. Now let's look at what happens once the rest of the world actually receives that urgent alert. It builds into a perfectly synchronized chain reaction mandated by Chapter 4.6. When the state of registry, operator, design, or manufacturer gets the alert, they have to follow a strict protocol. Step 1. They acknowledge receipt. Step 2, they immediately provide any relevant information they have right back to the state of occurrence, like known mechanical issues or crew details. Step 3, they officially inform the host country if they're going to send an accredited representative to join the investigation, including exactly when that expert is going to arrive. And within this massive chain reaction, there's one piece of data that is prioritized above almost everything else. According to Chapter 4.7, upon receiving the notification, the state of the operator must, immediately, with a minimum of delay, provide the state of occurrence with details of any dangerous goods on board the aircraft. Why? Because the first responders rushing to secure that wreckage need to know right now if they're walking into a toxic chemical spill or a radiological hazard. It is absolutely crucial for their safety. Now, you might be wondering what happens if the incident occurs outside typical jurisdictions, say smack in the middle of the ocean. Chapter 4.8 dictates that if the crash happens outside the territory of any state or in a non-contracting state, the state of registry, the country where the plane is registered, automatically takes over all those notification responsibilities we just talked about. The entire system is beautifully designed so that there is never a void. Someone is always legally obligated to trigger that global response. So I'll leave you with this thought. Considering the massive scale of international cooperation required just hours after an incident, cooperation driven entirely by the goal of future safety and never assigning blame, how does this invisible web of strict communication protocols keep your everyday flight safe? The next time you board a plane, just remember that there's an entire global framework detailed right here in Annex 13, standing by to ensure that every single lesson learned in aviation is shared with the world. Thanks for diving into this explainer with me, and keep learning.